This question is given that water flow from a tap of diameter 1.25 centimeter. So we can write this diameter is given as 1.25 into 10 raised to minus 2 meter with a rate of 5 into 10 raised to minus 5. So the value of volume flow rate is given as nothing but 5 into 10 raised to minus 5 meter cube per second. The density and coefficient of viscosity of water, the density is given as nothing but 10 raised to 3, and the coefficient of viscosity eta is given as nothing but 10 raised to minus 3. The flow of water is, so our aim is to find out its what type of flow, and the what about the value of Reynolds number. So we can write the equation for Reynolds number, that is V into D into rho divided by the value of coefficient of viscosity eta. So we can write the value of Reynolds number is equal to V is nothing but velocity flow. Over here the velocity of flow is not given, but we can write Q is equal to nothing but area into velocity. So we can write the value of this V as nothing but Q divided by area into density rho, density D into rho divided by the value of E coefficient of viscosity, which we can take it as nothing but eta. So we can write this as Q into diameter into density divided by area. We can take it as pi into r square, and r we can take it as d by 2. So this is going to be d square divided by 4 into the value of coefficient of viscosity eta. So 1d over here and 1d over here get cancelled. So we can write this is going to be 4q into density divided by pi into d into eta. So we can write this as 4 into the value of Q is given as 5 into 10 raised to minus 5 into the value of density is nothing but 10 raised to 3 divided by the value of pi, we can take it as 3.14 into density, which is 1.25 into 10 raised to minus 2 into the value of coefficient of viscosity, we can take it as 10 raised to minus 3. So I'll cut it as around 5095, or we can see that is near to 5100, and if it is greater than 3000 we can take it as nothing but a turbulent flow.